forging ahead with CO17 using relations to determine if an equation is a function. You can't spell function without fun. Oh, that one. We're in a good time today. We did have this last year. We talked about functions and how to tell if a relation is a function. So light bulbs might start to flicker on here as we move through it. But does anyone remember what a function is? Speaking about the coordinate plane, equations, relations, what is a function, Anthony?
Would it have a pattern?
Not necessarily a pattern.
A rule?
Not necessarily a rule. You're saying graphy things though, so that's good. Okay. A function is a relation where every x value has exactly one corresponding y value. A relation where every x value has exactly, I didn't write the word one, exactly one corresponding y value. Okay. A relation where every x value is exactly one corresponding y value, which in and of itself is kind of a confusing definition. Like even me reading it, know what a function is, it is kind of confusing. Okay. So I've got some examples here. I've got two relations that are functions and two relations that are not functions. Okay. And I want you to look at these two and see if you can come up with any reason why the two on the left would be functions, what's different about them, versus the two on the right that are not functions. Anything jump out at you? Adrian?
You can't have two of the same number in x or y, and the one on the left doesn't, but the one on the right, there's two nines in the y value.
Okay, so you are very, very close because we actually don't care about the y. We only care about the x. Okay, but Darth, I'll give it to you. Okay, what Adrian's saying here is that notice in the two function examples, read the definition, a relation where every x value is exactly one corresponding y. In these two examples here, when x is 2, y is only 9. That is it, nothing else. When x is 5, y is only 7. When x is 8, y is only 10. When x is 4, y is only 18. Whereas in this example, when x is negative 2, take a look at this. When x is negative 2, y is both 7 and 10? Doesn't make any sense, right? That would be like if you had an equation. I'm just making this up randomly, so you don't need to care too much about it. But if you had an equation and you plugged in a value for x, you'd get two different answers. That's not possible, right? X can only be one number. You can't get two different results by plugging in an x. And so the example that I give here, and sometimes related to birthdays, okay? Anthony, how many birthdays do you have?
I have one.
One. Is it possible for you to share a birthday with someone else?
Yeah.
Yeah. Is it possible for you to have a birthday on two different days?
I mean, no.
No. Functions work the same, okay? It's okay for two different people, such as 8 and 9, to have the same birthday. That's why we don't care about the y. If the y repeats, that's all right. 365 days in a year, 8 billion people, you're bound to have some repeats, right? So it's okay for y to repeat because that's like saying that two different people share a birthday. However, it's not okay for the same person to have two different birthdays, as we see here. It's not okay for the same person to have three different birthdays as we have there. It is okay for the same person, or for two different people to have the same birthday though. Okay? So basically, as long as x doesn't repeat itself, it's a function. right? The difference that we have here is, notice these x's, none of them repeat. None of them repeat. Here we've got an x that repeats twice. Here we have an x that repeats thrice. Okay? That's what makes something a function versus not a function. Was that some excellent teaching or what? Questions? Comments, concerns, complaints, compliments, congratulations, criticisms? All right, very well. Well, let's just kind of move on down then. You might get some time for your homework today, which I will assign very clearly at the end of the video. Stay tuned. So here we have some examples of some tables and then some graphs. Take a look at the tables first. Is the first one a function? Is the first one? Raise your hand if yay. The first table is a function. Raise your hand if nay. It's not a function. The yays got it, and you are correct. And the reason why it is because looking at those x's, none of them repeat. It doesn't matter that the y's do. These are three different people all sharing a birthday. Fantastic. Have a party together. Okay? But x does not repeat, therefore it is a function. Next one. Yay or nay? Raise your hand for yay, function. Or you're stretching. I see. Raise your hand for nay, function. It is not a function. And the reason why is because look at all these x's repeating. Right? The same person has 4 different birthdays. I'm not buying presents 4 times for the same kid for the birthday. All right? Next one. Raise your hand. Yay, function. Nay, not a function. It is a function. And the reason why is because x does not repeat. They're all different x's. Okay? All different x's. Lastly, yay, function.
Oh, wait,
Be
no,
bold, be
I
brave,
thought we were on the third one.
believe in
I
yourself.
looked at the wrong one.
Oh, okay. Last one, function yay. Oh, function nay. It is not a function. The reason why is because x repeats itself. Okay, and there we have it. So now on a chord plane, what it looks like when x repeats itself. Which one of these 4, 1, 2, 3, or 4? Thinking about, if x repeats, it's not a function. What would x repeating look like on the graph there? 1, 2, 3, or 4. Which one's not a function?
The third one. Second one.
Vote for the third one. Vote for the second one.
Actually, no, I'm going to go for the second one.
Go with the second one. Anybody else? Thoughts? Cool. It is the second one. Okay?
Oh, yeah.
The second graph here is not a function, and the reason why is because if you look at the x-axis, let's take the x value of 4. Okay? When x equals 4, there are 2 things that y could be. Because we have an x value of 4 up here at about 4, 4, and we have an x value of 4 down here at about 4, negative 2. Right? If we were to list those ordered pairs in a table, we would see that 4 repeated itself. So on the graph, when x repeats, making it not a function, the graph will kind of curve and fold over itself. We call this the vertical line test, which is described up here. If you can put a vertical line anywhere through the graph and it touches it in more than one place, bam, bam, it's not a function. Okay? All these other ones that are here, I can put a vertical line through as many times as I want to, and I'm only going to hit the graph in one place each time. That's because x does not repeat itself. There's only one y value for every x. It doesn't fold over itself. It doesn't overlap itself. Okay? So this one would be a function. This one is not a function. This one here, even though it's windy, curvy, topsy-turvy, is there any place where a vertical line will touch the graph in more than one spot? No. No, 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 no. Right? Which means x does not repeat, which means that it is a function. The last one is a little bit tricky. I tell myself every single year to change it to a different graph, and every year I forget. I'll probably stand up here a year from now and say the exact same thing. But These end lines here, they're not quite vertical. They look like they are, but they do gradually extend outward. So this one, like the others, any vertical line that I put down here is only going to hit the graph once. Therefore, this is a function as well. Okay. Questions on any of this? Okay. We've come to the end of the lesson, which is typically the spot where I assign homework. Okay. So this is where I'm going to assign your homework, which is going to be due tomorrow. You have some time to work on the homework today. If you don't finish the homework I'm about to assign today, then you can finish the homework that I'm about to assign tonight. So that tomorrow you'll come back with the homework I'm about to assign today completed. If we don't play the number game tomorrow, it'll be the travesty of all travesties because your homework is one question. It is only the brain buster down here at the bottom. I'm not going over this with you because that would mean you would have no homework, thus no number game tomorrow. However, in the spirit of Christmas, you all get this last question done, which is your homework for tomorrow, and we can do the number game. It says the ordered pairs of a function are 4, 3, -2, 1, 3, 6, 0, -5. What is an ordered pair that could be added to make the relation not a function? So right now, those 4 ordered pairs do create a function. What's an ordered pair you can add? A 5th ordered pair you can add. That will make it not a function any longer. Okay?
You didn't finish that.
All right. That's how you math.
Don't forget to, like,